The Create Space-Time Cube tools aggregate data both spatially and temporally, allowing you to perform analyses that uncover patterns and trends over space and time. When aggregating a set of points spatially, we consider their location based on their x and y coordinates and use a two-dimensional grid. However, when working with spatial temporal data, we have a third dimension to consider: time. Conceptually, it can be helpful to use height as a way to visualize the temporal dimension, where points at the top have the most recent timestamp. Now, to aggregate this data in a way that also incorporates the temporal dimension, we can create a space-time cube. You can think of a space-time cube as a three-dimensional grid-like structure where points are aggregated based on their location on the ground and their place in time. In this example, we can see that points falling within the same 10 kilometer by 10 kilometer spatial extent and that took place within the same month are aggregated together into a bin. Bins are the individual aggregation units that make up the space-time cube, each with a unique spatial temporal extent. The space-time cube counts up how many points fall into each bin and can also summarize numeric attributes if the points have any. Points can be aggregated into fishnet or hexagon grids or into any polygon layer. Alternatively, if your data does not require aggregation, you can create a space-time cube from defined locations where each point or polygon will become its own bin. Once your data has been aggregated into a space-time cube, you're ready for analysis. The Emerging Hotspot Analysis tool finds spatio-temporal clusters by extending the concept of what it means to be a neighbor to include not only what is near in space, but also what is recent in time. Within the space-time cube, each bin is evaluated in the context of its neighboring bins, which includes the bin's spatial neighbors, the ones that are closest geographically, and its temporal neighbors, the ones that are closest in time as well. So only bins that are both proximate in space and recent in time are considered related. With this three-dimensional conceptualization of proximity, each bin's neighborhood is defined and then compared to the study area. If the neighborhood value is significantly higher than the study area, then that bin is marked as a hotspot. Just like in a two-dimensional hotspot analysis, each bin is assigned a probability measuring how likely it is to belong to a non-random cluster of high values, a hotspot, or a non-random cluster of low values, a cold spot. The type and intensity of clustering is then summarized for each location and categorized based on the location's pattern or trend in clustering over time. There are 16 possible types of significance, 8 for hot and 8 for cold, each describing a unique temporal pattern. For example, this location has been marked as a sporadic hotspot, meaning that most recently it was hot, but over time it has switched back and forth between hot and not significant. This location is marked as an intensifying hotspot, meaning that it has been hot at least 90% of the time, and that there is a significant upward trend detected in the clustering intensity, meaning that the clustering is becoming stronger. The hotspot has been getting hotter over time. And this location is marked as a new hotspot, meaning that it had never been hot before until the most recent time period, when it became hot for the very first time. Emerging hotspot analysis is just one way to identify spatio-temporal clusters in our data. Local outlier analysis uses the same spatial-temporal conceptualization of what it means to be a neighbor to identify statistically significant clusters and outliers in the context of both space and time. Just like in an emerging hotspot analysis, a bin's neighborhood is defined in terms of spatial and temporal proximity. But in a local outlier analysis, the bin is not included in its own neighborhood. This allows for a different type of comparison, where both the bin value and the neighborhood value are compared to the study area to identify value clusters and detect local outliers. The result includes 4 possible types of significance. A bin with a high value surrounded by a neighborhood with a high value is marked as a high-high cluster. while a bin with a low value surrounded by a neighborhood with a low value is marked as a low-low cluster. Bins are considered outliers when their value is very different from their neighbors. So a bin with a high value surrounded by a neighborhood with a low value is marked as a high-low outlier, and a bin with a low value surrounded by a neighborhood with a high value is marked as a low-high outlier. The two-dimensional summary output of local outlier analysis tells us if a location has ever been significant, and if so, of which type. For example, this location has been marked as only high-high cluster, because over time it has been significant and only as a high-high cluster. While this location has been marked as multiple types, because over time it has been significant as both a high-low outlier and a low-low cluster. For both emerging hotspot analysis and local outlier analysis, combining the 2D summary output with a 3D visualization of the spacetime cube gives us valuable insights into where and when significant patterns and trends are taking place. Ultimately, by incorporating time into our cluster analysis, we're able to understand our temporal data in powerful new ways.